Hey everyone, sorry I couldn't be with you again today, but I really appreciate you guys taking the time to go through the notes with us and try your best on it, okay? When I do tell you to pause the video, I do want you guys to go ahead and pause and try to work through the problems on your own. That way we can see if you actually know what you're doing and get immediate feedback thereafter, okay? So let's start off here with the notes. Again, these are posted on Schoology, so you should be able to grab them and kind of work through them on your own, okay? Just do a split screen between YouTube and Schoology, and Notability, and you should be able to watch both of them at the same time, okay? So for the Unit 2 Objective 1 notes, what we're doing on this is we're actually moving into a unit where we are going to start solving of equations, and we're going to start with variables on one side and then both sides, and we'll kind of work through 5-step problems. So let's start with some examples here. It says, find the value of x in this problem. When we look at this problem, we can see that 15 stretches all the way across here. And when we look at the problem here for where we've got 8 already provided for us, that's this region right here, we're asked to figure out what's that missing part that would actually have to take place there so that everything is equal. So it says, what is the value of x? How did you figure it out? If we know that there's 15 in the entire thing and we've got 8, how do we find out that missing part? Well, here's what we know. We know that x and 8 together are going to equal 15, right? Those two combined together should add up to 15. Well, how do we find the missing part? Hopefully you did some mental math and you know that x is equal to 7. But how did you get that? Well, you know that 7 plus 8 equals 15, right? Another way that we could have done this was algebraically saying that if I took away 8 from both sides, we're going to be left with 7 for just that x value. So look at it like this. If I have an equal sign, and we know that there are 15 dots on the right side. I'm going to draw something out here, sorry. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And so far on the left side, we know we have 1, 2, 3, 4, 5, 6, 7, 8, right? And we have a missing amount, right? We don't know how many are missing. So we're going to just call it x, okay? I could slowly start taking things away from both sides because they're the same on both sides, right? We know we could take away one from here and one from here. We could take away one from the left and one from the right. Take away one from the left, one from the right. Take away 2 from the left, 2 from the right. Take away 3 from the left and 3 from the right. And what you will see is at the end of all this, we have remaining exactly 7. That's what's remaining on the right side, and that's what we would have to have on the left side in order to keep everything exactly the same. Okay? Let's move on to example 2. In this example, it says, what's the value of x? How did you figure it out? Same exact idea. We have an x here, we have another x, and we have another x. So we have 3 x's. All of those x's are going to add up to 12, right? And they have to be exactly the same. So mathematically, here's what we've got. We've got 3 x's that add together, and all of those are going to equal to 12, right? Now, some of you have done the mental math already, but when we add all these together, we end up with 3 x's. This is combining like terms. 3 x's are equal to 12. Hopefully, you were able to figure out that the answer of this, 3 times what number, 3 times some value is going to equal 12. And if you think about it, we know that x is going to equal 4. Okay? How do we get that? Well, 3x is equal to 12. In order to solve this, I could divide both sides by 3, and we end up with 4. And these 3's are going to cancel themselves out because any number divided by itself is always going to equal 1. So we're going to be left with 1x. Now, I don't have to write that 1. It's a little redundant to actually do that, so we just say I'm left with an x. And we know that x is equal to 4. If I go back and check it, we can say that 4 plus 4 plus 4, is equal to 12. So now using this process, let's go through and kind of figure out some other problems. And let's use what we figured out here, okay? When we had a problem where we had addition, in order to undo addition, we said we should do subtraction, right? Well, these go both directions. If we have a problem where we have subtraction, to undo it, we're going to do addition. When we had a problem where there was multiplication, in order to undo it, we said let's go ahead and do division. And actually, this goes both ways. Just like when we did PEMDAS before, please excuse my dear Aunt Sally, adding and subtracting are always grouped together. Multiplication and division are always going to be grouped together. So now you just have to figure out, all right, what has been done to your variable and how do I undo what's been done to my variable? Let's take a look at letter A here. We have an n. N is technically all by itself. That's what we want, right? But what we did to n was we added a 3. So if I add a 3 to it, in order to undo it, we're going to have to do a subtracting 3. Let's do that to both sides and see what happens here. If I subtract 3 from here and I subtract 3 from here, we end up with n is equal to, those 3's will cancel themselves out because 3 minus 3 is 0, and negative 7 take away 3 is negative 10. We have negative 10 as our answer. Even if we have fractions, the problem doesn't change. The idea is still the same. We have a g. It wants to be by itself. We took away 1/3 from g. What's the opposite of subtracting 1/3? Well, the opposite of subtraction is to add 1/3. Put a line down our equal sign here, and we're going to add 1/3, and we'll add 1/3 here. Okay, we end up with g is equal to, and then we have negative 2/3 plus 1/3. That gives us negative 1/3 as our final answer. How do we do fractions on our calculator? Negative 2/3 plus 1/3. Let me show you guys here. Okay. Clear. Negative 2 divided by 3 plus 1 divided by 3 gives us a decimal. To convert this to a fraction, you're going to say math, which is underneath the green button on the left. So you're going to say math, enter, enter on your calculators. And it should say negative 1/3. Okay. Now, where it says letter C and D, it says you try. I want you guys to pause the video right now and then go ahead and do the problem. Okay, now that you guys have paused your video, let's go ahead and start working through these problems. We have a P on the right side this time. It doesn't matter which side it's on, just look at where the P is. P on the right side has a plus 3.9 added to it. The opposite of adding, so we added 3.9. The opposite of adding is to subtract 3.9. So if we subtract 3.9 from both sides, we are going to end up with 3.9's cancel. We're left with P. Negative 6.5 and negative 3.9 is negative 10.4. That's our P value there. Okay. Take a look at letter D. Let's write what it says. The sum of x and 5. Sum means plus. So we're doing the sum of x and 5 means equals 15. So I added a 5 to my x. The opposite of adding 5 is we're going to subtract 5 from x. So let's subtract 5 from both sides. Draw your line to keep everything balanced. X will come down. 5 minus 5 is 0. 15 minus 5 is 10. So 10 is our answer there. Okay. We can put this in all different contexts, and at the end of the day, it's still the same kind of problems. Okay, so when we look at example 4, it says the sum of the angles of a quadrilateral is 360 degrees. That means all of the angles in a shape add up to 360 if it's a quadrilateral, meaning 4 sides. Okay, so if we add all these sides together, I'm going to do some quick math here. 110 and 90 is going to equal 200. And then another 80 means we're going to have 280. So x plus 280 is going to equal 360. Now, we added 280 to x, so let's go ahead and subtract 280 from x. If we do this, we're going to take away 280 from both sides, and we have x is equal to 80. Okay. Same thing with letter B. Let's go ahead and add these together. So 125 added to 132 is 257. We're going to add 72, and we have 9, 12, 1. We have 329 degrees. So x plus 329 is going to equal 360 degrees. All of the angles together will add up to 360. Since I added 329, let's go and subtract 329 to get x by itself again. So if I subtract 329 from both sides, we end up with x equals, what is that, 50, nope, 31. Okay. For example 5, same exact idea here. On January 22nd, 1943, the temperature of spearfish in South Dakota was 54. It fell from 54 down to -4. What was the change in temperature? This is just a review problem. It's not actually anything special here. So it's saying is that it went from 54 degrees all the way down to -4 degrees. Well, if we went from 54 down to 0, we went a total of 54 degrees, right? But if I go down further to -4, I've gone an additional 4 degrees. So the total change is 58 degrees. Okay, and we can, I don't know, you could say it went down 58 degrees. You could say it went -58 degrees. It's all the same in the end there, okay? Example 6 now is going to talk about multiplication and division. So in example 6, it says we have 27 is equal to 3 times x. When we look at x, I went ahead and said, let's multiply x by 3. So this says I did multiply by 3. Remember we said earlier that the opposite of multiplication is division. So let's divide by 3. Okay, if I do that to both sides, divide by 3, we end up with 3 divided by 3 is equal to 1x. 27 divided by 3 is 9. Remember we said we don't have to write the 1 that's there though, so we could just say that x is equal to 9. And we could do this for every problem. Look at letter B. I took the letter z and I multiplied it by 1.3. So since I multiply by 1.3, the opposite is to divide by 1.3. So if I divide both sides by 1.3, we're going to get that z is equal to, I got to do this one on my calculator, 1.5.2 divided by 1.3. We'll get 4. Okay, take a look at letter C. Now I want you guys to pay attention carefully to something here. Do you see this negative sign right here? Anytime you see a negative sign in the problem, I want you, in a fraction, I want you to attach it to the bottom. So this really reads as x, or 10 equals x over -2. Now that right there, that line implies division because we're dividing. So this says I have x and I divided it by -2. If I divide by -2, the opposite of dividing is to multiply. And so we multiply both sides by -2. Why do we do that? Well, if I have 10 is equal to x divided by -2 and I multiply by -2 on both sides, the -2 and -2 is like a -2 over -2. They just cancel each other out. They're equal to 1 again. And we end up with a -20 here is what x is equal to. Okay. Letter D, 2 times the number x is 60. 2 times, that's 2 times a number x is 60. So we have an equation, 2x is equal to 60. This means that we have x, we multiplied it by 2. So if I multiply by 2, the inverse is to divide by 2. If I divide both sides by 2, we end up with x is equal to, the 2's cancel, and we have x is equal to 30. Okay. Why don't you guys stop the video, try to do E and F right now by yourself. Okay, you try. And then come back and play the video. So in letter E, we're going to do what we said. We're going to take the negative, we're going to attach it to the bottom. This will be n over -5 is equal to -3. Since I divide by -5, the opposite is to multiply by -5. So if I multiply by -5 on both sides, whoops, -5, we'll end up with that 5's cancel, and we have positive 15 for our answer. In letter F, it doesn't matter that we have a symbol here that says pi. Remember, pi is equal to 3.14. So what we could do is we're going to say 2 is equal to x over pi. Since I divide by pi, the opposite is to multiply by pi. If I do that to both sides, let's multiply by pi. pi's cancel. We're left with x equals 2 pi. That's it. You guys ready for some harder stuff now? Let's try putting this together into a bigger problem, okay? In example 7 here, what we got now is we got letters and numbers, okay? Now think about what this says. We have an x, and we have another x, and we have another x, and we have another x. All of these are going to have to add up to 7, right? I'm sorry, all of these and 7 are going to add up to 27. So now we have to figure out what is that value for x. Talk with your group. Take a moment and pause and see if you guys can figure out. Talk with your group, okay? But let's look at this mathematically, what actually is happening here, okay? We have on the right side of our problem here, we have 27 dots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, right? On the left side of our equation, on the top part, we know that we've got that there are 7 dots already. But in addition, what we got is 4 separate x's here. There are x's here, right? There's 4 separate x's and all of those other dots that are there, right? What we can do is we can say, well, I can get rid of several of these x's, right? I can get rid of, I'm sorry, it's not the x's, the blue dots. I can get rid of 5 of those blue dots. I can also get rid of 2 more of those dots from both sides. Now what we know is that those 4 x's have to equal what's on the right side there. Well, when I look, if I split this up into 4 equal groups, we can see that each of these groups is going to have 5 dots in them. Mathematically, let's talk about what we just did here. We have 4 x's and we have a 7. So 4x plus 7, we have 4x plus 7 is 4x and 7 equals 27, right? Now, we combined a couple of things here. We know that if I have x, I multiplied it by 4. If I multiply by 4, the opposite is to divide by 4. We had an x there and we added 7. If I add 7, the opposite of adding 7 is to subtract 7. When we have multiple steps, what do you do first? Well, remember PEMDAS? This is why it's so important that you guys remember those steps. When we were doing PEMDAS, we were going this way with our problems, right? Now we're going to go the other direction with our problems. We are going to start with adding and subtracting first, and then we're going to do multiplying and dividing. Let's watch what happens when we do this, okay? Start first with this. If we added 7, let's take away those 7, like when we cross off those 7 dots. We're left with 4x is equal to 20. Now a 2-step equation has become a 1-step equation. Now we're going to say, well, I multiplied by 4. Let's go ahead and divide by 4. And when we divide by 4, look at what ends up happening. We have 20 divided by 4 is equal to 5, and the 4's cancel. We're left with x is equal to 5. We know that these 4 groups led to 5 in each one of our groups. There's your answer. So let's try it as a faster problem here, okay? We have 5 x's here. We have a 27, and all of that is going to equal the entire thing, which is 62. I added 27, so let's subtract 27. That's this part right here. I'm going to highlight it. Hang on. Okay, I added 27, so let's go ahead and subtract 27, right? And then I did multiplication by 5. So since I multiply by 5, I'm going to divide by 5. Let's undo these steps. Take away 27 from both sides. And we get 5x is equal to 35. Then we're going to go ahead and do the second step, which is to divide by 5. And we're going to end up with those 5's cancel, and we have x is equal to 7 for our final answer. And you can even check it. 7, 7, 7, 7, and 7. If you took 27 and added all of these values up, you would find that they all add up to 62. So let's go ahead and try solving some two-step equations here, okay? First, when we look at this problem here, we're trying to get x by itself. Think about what has happened to x, right? We have a minus 13, so since I subtracted 13, we're going to be adding 13. I multiplied by 2.5. So since I multiplied by 2.5, I'm going to divide by 2.5. Let's undo these steps now in that order, adding and subtracting first. Add 13, we get 2.5x is equal to 15. The 13's cancel. Since we multiply by 2.5, we divide by 2.5. We'll end up with x is equal to, let's go 15 divided by 2.5. And we end up with a fraction. Whoops, no we don't. 15 divided by 2.5, we end up with 6. So we have x is equal to 6. All right, take a look at letter B. Same thing. Now you have to fight something here. I know everybody wants to look at this and say that that's going to equal 20. That is not the same as 15x and 5x. Those are different. These you can combine and say 20x. These do not combine. One of them has an x, one of them does not. So you cannot combine them. So we have to keep them separated. When we look at what this says, you're allowed to rearrange things into being the order that you want them to be, right? Like this is a positive 5x, I can write positive 5x. This is a positive 15, I can write positive 15 is equal to 20. Just by making those slight changes, hopefully that kind of makes it so it's a little easier to look at this problem, right? I added 15, so let's subtract 15. I multiply by 5, so let's divide by 5. Let's do it. Subtract 15, we get 5x is equal to 5. Divide by 5, we get x is equal to 1. And when you get the hang of these, get pretty quick. Okay, example 10. The sum of 3 times the number n and 5 is 20. Okay, let's undo all that stuff and let's go ahead and talk about those parts. Okay, sum means addition. 3 times the number n looks like this, 3n. 5. The sum of these two means add. So 3n plus 5 is 20. Look at the steps here again. We added 5, so let's subtract 5. We multiplied by 3, so let's divide by 3. Let's do it. Minus 5 minus 5. 3n is equal to 15. Divide by 3, divide by 3. N ends up equaling 5. Okay. Now, these last couple ones require an extra step. In this case, what we're going to do is we're going to be combining like terms. So if you struggle with combining like terms, you may want to go back and do the practice on Delta Math for combining like terms. Okay. But you'll see that it leads to our same problems we just did. There's just an extra step. Let's look first and see if there's any like terms on each side of our equal sign. On the left side of our equal sign, we can see that there's 2 things that can combine, the 9x minus the 6x. Those combine and give us 3x. We still have this plus 2 is equal to 12. Now we're back to a 2-step equation, which we just practiced. Think about what happened here. I added 2, so let's subtract 2. I multiplied by 3, so let's divide by 3. And let's do those steps. Subtract 2, we get 3x is equal to 10. Divide by 3, and we get that x is equal to 10 divided by 3. Sometimes fractions happen. They're okay. They're still numbers, you guys. All right, let's take a look at letter B. Is there anything we can combine on the left side? Left side won't change at all, so let's just bring it down, negative 12. The right side, we can combine a 4x and a positive 2x. Look at it carefully. That's a 4x and a positive 2x. That combines to give us 6x. Then we have minus 15. Okay. Now look at the right side because that's where our variable is. I subtracted a 15 here. So let's do the opposite, which is add 15. I multiplied by 6. So let's do the opposite, which is to divide by a 6. Okay. And let's do both of those steps. Add 15 to both sides. We're going to end up with 6x. Those cancel, and we have 3. Divide by 6, not by 3, but by 6, because that's what it says. And when we divide, put this in your calculator. 3 divided by 6 is not 2, you guys. 3 divided by 6 equals 0.5, which as a fraction is 1/2. Okay, always check your work, 1/2. There we go. So these are the last 2 problems from the notes, I believe. Let's have you guys go ahead and pause it and try to do them on your own. Okay? All right. Now that you guys have paused it and done it, let's go ahead and check our answers here. Let's start with first, combining like terms. On the left side, we have a 3n and a negative 2n. Those will combine to be 3n minus 2n, which is just 1n. Then we have plus 8 is equal to 9. I added 8, so let's subtract 8. I multiplied by a 1, but I actually don't need that 1 there, so we could just ignore it. That means the only step we have to do is subtract 8 in this problem. And we get that n is equal to 1. Okay. The second problem, we have negative 2x and negative 10x. Negative 2x and negative 10x will give us a negative 12x. Then we have plus 12 is equal to 18. I added 12, so let's subtract 12. I multiplied by negative 12, that's this part right here, so let's divide by negative 12. Okay, let's do our steps. Subtract 12. We have negative 12x is equal to 6. Divide by negative 12, and we get that x is equal to negative 1/2. There you go. Hopefully this works with you guys. You understand kind of the gist of it. What you're going to be doing now is you're going to be practicing Delta Math. Okay, this is your assignment for tonight. Delta Math has problems where it says solving equations. Okay, and your assignment is going to start you off with 1-step problems and then slowly segue into 2-step problems, even some problems that have fractions. I just want you guys to spend some time doing that for practice, and we're going to go over that next class, okay? Thanks for listening. I hope it helped. You guys have a great day, and be good for the sub, please, okay?